What's up, everybody? You're on Pick of the Week. This is Math with me, Daniel Dallas, alright? So today I picked up A-Level Pure 1 due to recent exams, and I decided to clarify some terms, some questions related to parallel and perpendicular lines. I've prepared exam styles questions. I think that's gonna be really easy and helpful to consider those problems. So we have problem 1, which is pretty simple one, pretty standard one, like sort of EUP level. And here is going to be definitely challenging, especially the second question. Second question be about the distance. Alright, so fix those two problems, grab your pens, grab your notes, try to do by your own as always, and I'm gonna explain in a few seconds. And we start off from the first problem. The problem is pretty much simple and obvious. So you have line 1, you have line 2 with another equation in gradient-intercept form. So m is the gradient. And given that those two lines perpendicular to each other, you need to find out the value for m, basically for the gradient. Alright, so what we can do, the best way is to simply rearrange equation in order to find the gradient for the line 1. So that's what I'm going to do right now. From 3x minus 4y, I just make y as the subject here, and I'll have 3 over 4x and minus 3 over 4. Basically, I divided both parts by 4. Alright, so from here, this is L1. From here, we can figure out that the gradient for this line is 3 over 4 as the coefficient before x. So coefficient before x for the line 2 should be reciprocal. So that means m value is going to be a reciprocal with negative sign related to the first line. So that means m value is going to be negative 4 over 3, and hence we can establish the equation for the line 2, which will look like negative 4 over 3x minus 2. Alright, so let's move to the second question. You need to find coordinates of P, where point P is the point of intersection. So here I just set up those two lines, and here is the point P. So that's L2. Here is L1, and we have everything in order to define. So there are several cases, but if you want to show your workings, of course, you are not eligible to use calculator, just plot and see graphically the solution here. So we're just going to do it normally, just come back here, and what we're going to do, we're going to set up x and y coordinates for point P. That means both equations for line 1 and line 2 arrange simultaneous equations. So that means we can do the following. That's the first, 4x over 3 minus 2. That's equation from the previous workings. And here is the second equation for the line 1. I'll also rearrange in this way, so you can see it right here. It's going to be 3x over 4 minus 3/4. And now what I'm going to do, I'm just going to equate both y's to each other in order to solve that. And we have 3x over 4 minus 3 over 4. That will be equal to negative 4x over 3 minus 2. What I'm going to do, I'm going to multiply both parts by 12. So that's what I'm going to do in order to, so 12 is LCD for denominators 4 and 3. So that basically allows me to eliminate denominators. Alright, so after doing that, I will come up with the equation negative 16x and, sorry, I just started from the second part. Okay, so we'll get 9x minus 9, and the right side is going to be negative 16x, and minus 2 times 12 is going to be 24. And right now we have 25x equals negative 15, so x is negative 15 over 25. So of course we can present this result in the simplest form. So that means we're gonna have x value as -3 over 5. Okay, and just plug in this x instead of x in any equation you like. We can figure out the y value. So that means we'll get around -24/20, and that means we'll get -1.2 in decimal form, and this x also we can convert into decimal form as 0.6 and negative, so that's alternative way. All right, so I just fixed this result and I put the points, the coordinates for point P right here. Okay, so P will have the following coordinates. It's going to be -0.6 and -1.2. So that's the solution for problem 1. All right, we just move next. So, and we're on a second problem. Here is a line which is parallel to the given line with equation 2x minus 3y. So that means we can immediately find the equation in the form x plus by plus c for the line that passed through the point -1 and 3. So what we're going to do, because lines are parallel, that means this part of the equation for the second line, for this line, is going to be pretty much the same. So I mean, it should be actually the same. So we consider in general form, but if you just go back to intercept, gradient intercept form, you'll definitely have the gradient 2 over 3 for the second line as well as for the first. So that means it's easier because we need to give our answer in this form, in general form, in sort of like linear form. We're going to use the same part, 2x minus 3y, and plus some unknown c value, which we need to determine for this line. All right, so we established that a is 2, b is -3, and right now it's all about finding c value. What we're going to do, we just need to plug the point -1 and 3 into equation and solve for c. So -2 minus 9 and plus c equals to 0. From here c is 11. All right, and general equation of this line will look like 2x minus 3y and plus 11. That will finalize our solution right now. Okay, so we established the equation for the line, and we just need to go to part B. We need to find the shortest distance between those two lines. All right, in order to solve, just have a look at this picture. So we have the line that we originally had. So this is line L1, so this is line L2 with the equation that we recently established. And we just move somewhere in order to define the distance. All right, so before just going there, I would like to say that distance is the perpendicular between those two lines. All right, so no matter where you put this perpendicular, but for some obvious reason, I would start from point 2, and from point 2, I just drop the line, which is going to be, which arranged a 90 degrees angle with both lines. So that means those angles are 90 degrees. So we have the starting point, and in order to find distance, we need to find the value, the coordinates for some point M with x0 and y0. All right. So let's mark this line L3, and the general equation gradient-intercept form for the line L3 is going to be in the form -3 over 2x plus c. Why did I take this value -3 over 2? Because the gradient for both lines L1 and L2, 2 over 3. For the line L3, which is perpendicular, the gradient is going to be reciprocal. All right, hope you understand that. And from here, we just need to plug the coordinates 2 and 0 in order to find C. So let's plug the coordinates 2, 0 because our line L3 will pass through this point, and that means we'll get -3 plus C, which means C is 3. Okay, so now we have the general equation for our line L3, and it's gonna be -3 over 2x and plus 3. Now, because we have this equation, what we're gonna do, because we need to find the coordinates x0 and y0, we'll be looking for the coordinates of the point of intersection of line L3 and the line L2, which is marked as the purple one. So right now, what I'm gonna do, we'll be looking for the coordinates for this point x0 as the point and y0 as the point of intersection of those two lines. All right, so for this reason, we just need to solve two equations. All right, the system of two equations. The first is for the line L3, but I'll rewrite in a bit different way, so I'll multiply by 2, and that means we'll get 2y plus 3x equals 6. Oh, just transfer 6 here, so -6 equals 0. I multiply everything by 2. And for the line 2, so this is line 3, and for the line 2, we have already had an equation, 2x minus 3y, it's right here. 2x minus 3y plus 11 equals to 0. And now we're just going to solve that simultaneously. I'm not gonna do like waste your time, just use the equation solver, system solver, no matter how you do that, or even manually. But so it's gonna be pretty much easier to deliver solutions. So x0 coordinates is gonna be -0.31 to 2 decimal places. And for y0, we're gonna have around 3.46. All right, so now we have m coordinates with those values, x0, y0, that we found recently. And right now, we are going to plug into the formula for distance. So right here. So that means we finally can get the solution for using this formula for our second part, and the solution is around 3.47. All right, so that was questions, pretty challenging. The second problem definitely is going to be pretty challenging questions, but this is demonstration how the orientations of the lines allow you to derive the equation of the line in any form you like, and also on top of that solve other questions related to the lines that goes through different points. And I hope you clarify this concept. All right, so see you next time. Enjoy. And knowing coordinates x0 and y0, we can write the formula for the distance between 2 points. So that means we've got one point with coordinates 2, 0, and we're gonna use also coordinates x0 and y0 for point M, and find just using the distance formula, right? Well, basically it's based on Pythagoras, if you like. All right, so we're gonna have 2 minus x0 squared and y0 squared additionally. So our primary goal is to find the coordinates x0 and y0. So what we're gonna do, we just need to know the equation for the line, let it be line 3, that goes through the point M and through the point 2 and 0. Knowing the equation, we can establish the coordinates for x0 and y0, and from there we can find the distance finally. Okay, so let's do this.